Hello, I'm Mark. I am a senior R&D engineer at UniKLasers. First of all, Raman microscopy is a method of measuring the vibrational energy states of small items such as biological cells or small quantities of chemicals. Where traditionally when light is incident on a material it will be absorbed then re-emitted scattering at the same wavelength, this is called Rayleigh scattering. Raman microscopy instead used Stokes scattering, and this involves when light is incident on a sample and either gains or donates energy to the vibrational energy states of that material, giving information about them. This is a very rare process compared to Rayleigh scattering, and therefore quite difficult to detect, requiring good filtering of the incident light wavelength. You want very specific lasers for this. You want narrow linewidth lasers. This enhances your resolution, and you also want them to be quite intense, allowing for large sample processing rates. Additionally, depending on the sample you use, you'll want a different wavelength of laser. This can be in the UV, visible, or near infrared. For example, if you have a biological sample and you illuminate it in the UV, it's quite possible you'll damage or vaporize it, so you might want to use an IR beam. Well, for a crystal, for example, you may not care about that, but you want very high signal, where a UV signal may be more beneficial. This is quite a complex field and you need knowledge of your sample to optimize this. Applications are in various fields, in biology, pharmaceuticals, semiconductors, for example. It can be used for identifying materials, measuring the different levels of two chemicals within a sample, or determining the authenticity of an artifact in a museum, for example. A more advanced method of Raman microscopy is confocal Raman microscopy, where you combine the abilities of a confocal microscope, which limits the acquisition area to a small 3D volume, with the Raman technique, and this can allow you to measure in 3 dimensions the signal from sample, allowing you to go subsurface. For example, maybe you've modified a crystal and you want to measure how this has changed with depth.